I had to move subtraction over to a separate video. So this is going to be still Math Base 10, addition and subtraction. Math, the 5th week. This is going to be the 4th video. So I've written this is called a standard algorithm. I've written my standard algorithm over here. Take some time and to go ahead and fill in what you think might go in here. Just tell me, talk to the computer or the cell phone, and what do you think would go into each one of these? What do you think, how many thousands would I have up here in this top number? If you said 7, you're correct. How many hundreds? There's 100. How many tens? 2. And how many ones? Okay, so the arrangement, the starting point is the same as if we're doing addition or subtraction. Because this is the base 10 system. It's always going to look like this, no matter what we do. Let's start with the next number. We have a 4. We have a 6. We have a 5. And we have a 9. Now we're going to be subtracting. This is a little bit more difficult, so kind of pay attention. If we have, you have to know what number is the largest number in subtraction. The smaller number always goes on the bottom, and the larger number always goes on the top. You cannot reverse this in 4th grade and come up with a difference. So our answer here is going to be called our difference. You cannot reverse these. In 6th grade and 7th grade, and certainly by 8th grade, you can reverse these numbers and come up with what's called a negative number. But negative numbers are, you're going to get those later on in middle school, not right now. So we have a problem here in our ones right off the bat. And the problem with our ones is 4 is smaller than 9. Even though 4,000 is the smallest number over here, this ones is smaller than the 9. So we really have already learned in our previous grades, we can't take 9 away from 4 because there's not enough to be taken away. You're going to run out at some point. So this is where we're going to take some 10s and we're going to move a 10 over into a 1. This is going to be one of the 10s. We got 2 of them. We're going to move one of the 10s over here. So if we have 2 10s and we move 1 around, this is going to change this to 110. And this 10 is going to come over here. And if you remember, our 10s, we can just go ahead and put a 1 next to that 14. That's the same as increasing from 4 10s, from 4 1s to 14 1s. Okay, so let's just do this part right here. Let's take 14 minus 9. Now this number is big enough to subtract 9 from. And 14 minus 9 is 5. So that does seem a little bit more complicated, huh? So we took this 10, we moved it over here. We're done with that 10 now. We still have 1 10 left over here. We had 2. We moved 1 over to the 1's place, and now we have 1 left. Now here we have 1 minus 5. Again, we have 1 10s minus 5 10s. This is too small of number. We can't remove 5 10s from 1 10s. It's impossible. So we're going to move one of our hundreds over to this 10s place. So this becomes 0, and we're moving a hundreds over to our 10s place. And we learn that we can just do this. This is now in the hundreds place over here. And we come up with 11 10s. 11 10s is the 1 10s that we had and 10 10s that we moved from our hundreds. Do you see how the base 10 number system works in subtraction? So now we have 11 minus 5. This number is big enough now to subtract 5 from. And 11 minus 5 is 6. Let's go over to our hundreds. So we took care of that hundreds. We have 0 over here. Now, some get confused. Don't be confused. If you have 0 minus 6, this number still has to be, since we're using subtraction, the larger number. Which one of these two numbers is larger? Yes, the 6 is larger. So we have to make this number larger than 6. And how we do that is we're going to take one of our thousands and move it over there. So we're going to take 1,000, and we're going to move it over to our hundreds place. So we had 7 thousands. That's going to take one of those thousands, remove it, and move it over to the hundreds place. And how do we show that we moved a thousands over into this hundreds place? That's a little confusing, but there's 10 hundreds in 1,000. So we just moved 10 hundreds over here. We had 0 to begin with, but we just put this 1 over here. We shortcut it a little bit. We put this 1 over here, and that gives us 10 hundreds. Now what's the largest number? The 6 or the 10? The 10 is the largest number. So let's take 10 minus 6, and that's going to give us 4. Now over here, let me cross that thousands out. We already used that thousands over in this hundreds place. Now over here we have the 6. Which one of these two is largest? 4 or 6? If you said 6, you're correct. So we don't have to do anything over here. We don't have to move anything around because this number is already large enough to subtract this number from. We have 6,000, and we're going to subtract 4,000. 6,000 is larger, so we don't have to do anything over here except do our simple subtraction. 6 minus 4 is 2. And this is the number we get. So, in addition, we can kind of set it up this way. For subtraction, that's why it gets too crazy. We can't do this for subtraction. We have to do subtraction by moving imaginary place values over to the next smaller place value. So we can move tens over to ones. We can move hundreds over to tens. We can move thousands over to hundreds. We don't go the other way. In addition, it moves it over automatically for us. In subtraction, we have to think them through. This is what makes subtraction so different. So now I'm going to show you the standard algorithm over here. I'm going to do the same thing over here I did over here, but I'm going to kind of shortcut it. And some of you may already know this method. 4 is smaller than 9, so I'm going to have to take a 10. This becomes 1. I'm going to have to take a 10 and move it over to my 4 over here. So that becomes 14, just like I had over here. So 14 minus 9, we said, was 5. Now I have my 1 minus 5. I'm going to have to move a hundreds over to my tens. Now I have 11, just like I have over here. 11 minus 5 is 6. Now I have my 0 over here. And remember, the larger number has to be at the top. So this is not, the answer over here is not 6. Because we can't subtract 6 from 0. If you have nothing, you can't remove 6 from it. So this number still has to be the larger number. So I'm going to take one of my thousands. That's going to give me 6 thousands over here. And I'm going to move one of my thousands over here. Actually, I'm going to move 10 hundreds over there. Now this number is large enough to subtract. 10 minus 6 is 4. And over here, this number is sufficiently large enough to subtract with. So I have 6 minus 4, and that gives me my 2. Do we have the same numbers here? Yes. I have a difference of 2,465 over here, and I have a difference of 2,465 over here. Both these examples, and using base 10 for addition and base 10 for subtraction, you should be able to do in 4th grade. It's a little bit hard. We're going to practice those at home. And as well, you can use the shortcut method on your scary math over here if you'd like. This is a little bit hard to understand. We're getting an early start in the year on it. You probably didn't know that addition and subtraction could be so difficult, but the important thing is that you understand how the base 10 number system works for addition and subtraction. We kind of did a little bit of that with multiplication. It was almost easier in multiplication. But in addition subtraction, addition's not hard, subtraction's hard. Practice with the numbers that I give you on your worksheets and see if you can do the same thing.